Hey sixth graders, this is 7-6 ratios and multiplicative comparisons. We're going to be doing some work today describing ratios with equations and with multiplicative comparisons, and we're going to kind of see how we can use visual pictures with a basic ratio like this to do a bunch of work. So this first page is going to seem overly simple, but I think it'll kind of help us prepare for the rest of the lesson when it gets a little bit more complicated. All right, so we're going to start off. Different ways to describe ratios. Seth made a sand mixture by mixing 4 parts green sand with 3 parts yellow sand. And that's pretty simple. You can see that in the picture right here. There's 4 parts of green and 3 parts of yellow. And by the way, just like in our last lesson, I think it would be good to note, what is the total mixture of sand here? How many parts? Is going to be 7 parts. Because you can count the total, there's 4 parts green and 3 parts yellow, so that 7 is made up of 4 plus 3. That's going to come into play a little bit later. All right, so we're just going to complete some sentences based on this picture from the information they gave us in the original sentence. It says, the mixture is blank parts green sand and blank parts yellow sand. Well, how many parts green? 1, 2, 3, 4. And how many parts yellow? 1, 2, 3. All right. Green sand and yellow sand are mixed in a ratio of blank to blank. Well, when you do ratios, you want to make sure that everything stays in the same order. So if it says green first and yellow second, that's what we need to write. Green first is 4 and yellow second is 3. So their ratio is green to yellow is 4 to 3. Or another way we can write that is 4 to 3. But in math, you can write the colon like you see when you tell time, those 2 dots. In math, you read that out loud with the word 2. So you say 4 to 3, 4 to 3. These say the exact same thing. For every blank cups of green sand, there are blank cups of yellow sand in the mixture. All right, so every 4 cups of green sand, there are 3 cups of yellow sand. So far this is really simple. It just has to do with the number 4 and 3 looking at the picture. Let's move on. Complete each sentence to describe the green sand to the total ratio. So in this first section, it was green sand versus yellow sand. This time, it has moved to saying green sand versus the total. Green sand versus total is going to be 4, there's 4 parts green, and how many parts in the total? Well, we started off figuring that out at the beginning, and there are 7 parts in the total mixture. What's the green sand and total mixture ratio? We can say green sand comes first, which is 4, 2, and the total is 7. I don't like how they broke that up. The way I would write it is 4 to 7. I don't like how it's kind of split on 2 different parts of the line there. 4 to 7 is what it should say. Or another way to write that, just like above, 4 colon 7. 4 to 7. For every blank cups of green sand, there's blank cups of mixture. So every 4 cups of green, there's total 7 cups of mixture. All right, so describe the yellow sand to the total ratio in 3 ways. Okay, so basically they're having us compare yellow to the total instead of green to the total. So in our last section that I did in pink here, it was all the green versus the total. This time it's going to be all the yellow versus the total. But they didn't help us by giving us sentences. We have to write the sentences. I'm going to use what they used here as a model. So there are blank parts. Instead of green, I'm going to say yellow because that's what it tells us we're focusing on, is yellow to total. So there are blank parts yellow sand in blank parts total mixture. Now, what are the answers? There are blank parts yellow, 1, 2, 3, in blank parts total mixture, 7. okay? So the way we can write this is going to be, this one up here said green sand and total mixture, so I'm going to change that to yellow sand and total mixture. Are in a ratio of yellow versus total. So it's going to be yellow, which is 3, to the total, which is 7. Or another way we can write that is 3 to 7 with the colon. So yellow sand and total mixture are in a ratio of 3 to 7, or another way to write that is 3 to 7. All right, last sentence is going to be like number 6. For every blank cups of, I'll change that to yellow sand. For every blank cups of yellow sand, there are blank cups of mixture. And we're talking about yellow sand first, so that comes first. For every 3 cups of yellow sand, there are blank cups of mixture for the total, which would be 7. All right, so this first page hopefully felt like kind of shockingly easy, okay? It does get more complicated though as we start moving into the next page where it starts talking about the multiplicative comparison, which has to do with comparing how is yellow versus green. It's going to end up involving fractions, which always get a little bit more confusing. So here's what it looks like. We've got this first section, which says complete each tape diagram. And what we're going to be doing is determining the fractions, just like we did in our last lesson, of how much is each part. So on our first page, we just assumed that each part was 1. Each of these little green boxes was worth 1. Well, now we're going to say that this whole section right here that's green, that is 1. So if we share that with 4 parts, each one of those is going to be 1/4. Okay? That's because if this whole thing is 1 and we share it equally with 4 sections, they're all worth 1/4. And all the parts are equal to each other, so these are all equal to 1/4 as well. Some kids go, well, how come the bottom part isn't 1/3? Well, because this yellow part is not worth 1. It's the green part that's worth 1. And then we can say, well, how much is that yellow part worth? Well, there's 3 groups of 1/4. So 1/4 plus 1/4 plus 1/4 is 3/4. And then how many total cups is that all together? 1, 2, 3, 4, 5, 6, 7/4 of a cup. And of course we could rewrite that as a mixed number, but for the purposes of this lesson, we're just going to keep it as an improper fraction. All right, so that was if green was worth 1 cup. Now we're going to look at, well, what if yellow was worth 1 cup? Okay, if yellow was worth 1 cup, then you're sharing 1 cup equally with 3 different parts, which means each part is 1/3. And if all these parts are 1/3 and all the parts are equal, that means all the green parts are worth 1/3 as well. So how many cups is this green section worth? 1, 2, 3, 4, and they're all the size of thirds, so there's 4 thirds there. How many cups are total in the green and yellow together? If we have 1/3 of a cup plus another 1/3 of a cup plus another 1/3 of a cup, that means there's a cup of yellow there, and we put that together with 4/3 cups of green, you could add 1 whole plus 4 thirds, or you could just say 1, 2, 3, 4, 5, 6, 7 all together. That's 7/3 of a cup. There's one more way to look at it. What if instead of the green being worth 1, or instead of the yellow being worth 1, now the total sand is 1. So if all of this together is 1, there's 7 parts there that we have to share equally to come up with 1. So that 1 is divided into 7 equal parts. So each of these little parts is worth 1/7. Which means that for the yellow, all together, we have 3/7 of a cup. And the green altogether, we have 4/7 of a cup, which should make sense because if you put together yellow plus green, you'll get the total. And we know that 4/7 plus 3/7 equals 4/7. Equals 7/7, and 7/7 is a whole. Okay, so this is 3 totally different situations. They all have the same ratio of 4 parts green to 3 parts yellow. It's just that there's different unit rates. Like in the first one, your green sand is all worth 1 cup. So you had to determine how much yellow there was. In the second situation, it was the yellow sand that was 1 cup. So we had to figure out how much green sand there was. And in the third situation, it was the total that was worth 1. So we had to figure out how much yellow and how much green there was based on the fact that the ratio was 4 green to 3 yellow. All right, so now we get to interpret what these 3 pictures are telling us. The first one says, blank cup of yellow sand for every 1 cup of green sand in the mixture. So if there's 1 cup of green, which one of these is it talking about? This first one, because green sand is 1. So if there's 1 cup of green, the question is how many cups are yellow? 3/4. Okay, now the next one, how many cups of green sand are there if there's 1 cup of yellow? Well, 1 cup of yellow is the second one because it says yellow sand is 1. Okay, so when there's 1 cup of yellow, how much green sand was there? 4/3 of a cup. The third question is, how much of green and how much of yellow if there's 1 cup of mixture? In other words, if the total is 1, that's going to be this last situation. If the total is 1, how much green sand would there be? 4/7. And how much yellow sand would there be? 3/7. And that's if the total is 1. All right, so blank cups of mixture for every 1 cup of green sand. So what that means is if there's 1 cup of green sand, which is right here, if the green is 1, how much mixture is there? In other words, what's the total? 7/4. And then the next question is, how much cups of mixture, what's the total, if there's 1 cup of yellow sand? So then we go to the second one, because if yellow is 1, if there's 1 cup of yellow sand, that's the second picture, how much total mixture is there? 7/3. All right, so now we're going to use this idea of multiplicative comparison, which sounds really complicated. It just means, how do you compare the yellow versus the green, or the yellow versus the total, or any combination of those using those fractions? So the amount of yellow sand is blank times the amount of the green sand. So what we do is we go, well, if the green is 1, then how much yellow is there compared to the green one? So if green is forced to be 1, we're looking at this first one, how much is yellow compared to that? Yellow is 3/4 of the green one. So it's 3/4 times the amount of the green, because yellow is 3/4 if green is the total. Yellow is 3/4 of the total of green. Well, then if we look at the opposite way, what's the amount of the green sand? If it says the green sand is blank times the amount of the yellow sand. Okay, so if the yellow sand is now your whole, right here, the amount of green is how many times that of the yellow? Well, green is bigger than the yellow, so I know that the green is going to be larger than a whole, and we're looking at this answer right here. It's 4/3 times the amount of the yellow, because if the yellow is 1, our unit, then the green is 4/3 of that. Number 18, the total amount of mixture is how many times the amount of green sand? So if you look at when green is 1, that's back to this first picture. What's the total if green is 1? 7/4. Okay, the total is 7/4 times the amount of the green sand. And same with the next one. The total amount of mixture is blank times the amount of the yellow sand. So if the yellow sand is 1 unit, which is right here, if the yellow is 1, how much is the total compared to that? The total is right here, 7/3 times the amount of the yellow sand. All right. So our next little section is a Puzzle Penguin moment. It says, "Dear math students, I made my own sand mixture. I mixed 2 parts purple and 5 parts orange." You can see that in the picture. 2 parts purple, 5 parts orange. So far, I don't see anything wrong with that. Then I wrote this multiplicative comparison, which is what we were just doing in the last section. It says the amount of purple sand is 2/5 times the amount of the total mixture. My friend says I made a mistake. Did I? Well, we already know he did. He always does. If I did, can you tell me what mistake I made and help me correct it? Your friend, Puzzle Penguin. Yes, Puzzle Penguin, you did make a mistake. Let me talk about it. You said the amount of purple sand is 2/5 the amount of the total. That is not true. What you did find is this. So you found that purple is 2/5 times the amount of orange, okay? Puzzle Penguin, this is where you messed up. You said that the purple was 2/5 of the total, but it's not. Purple is 2/5 of the orange, because if the orange, right here, if that unit is worth 1, then that means if we share that 1 with 5 parts, this is worth 1/5, 1/5, 1/5, 1/5, 1/5, 1/5, 1/5. You guys get the idea, okay? So 5/5 together equal a whole, and the purple is 2/5 if you add it together. So that purple is 2/5 of the orange. But Puzzle Penguin, you said it was 2/5 of the total. It's not 2/5 of the total. If you want to find 2/5 of the total, then here's what you need to do. The total, I'm going to make a new picture for you. 1, 2, 3, 4, 5, like this. This is purple, this is orange, okay? How many is in the total? 1, 2, 3, 4, 5, 6, 7. Okay, there's 7 in the total. So this all together is the total. In parentheses, I'm going to say it's worth 7 parts. Okay, so if you want to find out how much purple is versus the total, then what you need to say is that you have your purple versus the total, which is purple, which is 2, and total, which is 7. So what you should have said is purple is 2/7 times the amount of the total mixture. Okay, so basically, Puzzle Penguin, what you did is you found purple versus orange, which was 2/5 the amount of the purple versus orange, okay? What you should have done if you wanted to find purple versus the total is you should have said, well, 2 is purple and 7 is the total. So purple is 2/7 of the total mixture because the purple part is 2 and the total part is 7. So Puzzle Penguin, you just got confused between comparing the 2 colors and comparing the purple versus the whole thing, which was 7. So it should have been 2/7. All right, now number 21. Let G be the number of cups of green sand in Seth's ratio, and let Y be the number of cups of yellow sand in Seth's ratio. So here's the picture. Discuss why these 3 equations can all be used to relate G and Y. Okay, so there's not a lot to actually do here. We're just discussing. So we have this first one, which says 4/3 equals G versus Y. I'm going to write this bigger. I'm not sure how much you can see it on my camera here. This is the first one. Why is this true for this picture? Well, because when you set up a proportion, it has to be things that are things that are similar on both the numerator or both the denominator. Okay, so we've got right here 4 is what the green represents. Yes, I can see that in my picture. And 3 is what the yellow represents. I can see that in my picture. So that's why this one is true. The first one is basically just showing exactly what's in the picture. There's 4 greens and there's 3 yellows. Okay, so what about the second one? Why is this one true? Again, I'm going to write it bigger. I'm not sure how well you can see that tiny writing in the video. Second one says this, y equals 3/4 of G. Yellow is 3/4 of green. Well, yes, it is, because right here, if you're comparing yellow to the green, yellow is 3/4 the size of the green one. If the green is your whole, if green is 1, then yellow is 3/4 of that size. Okay, and remember in math, of means multiply. So it's like saying 3/4 of your green. Yellow is 3/4 of your green. Okay, now the third one says 4/3 y equals G. Why is this last one true? So 4/3 of, remember when you have a coefficient and a variable together, you're multiplying them. So even though there's not a multiplication symbol there, it means we're multiplying, which in math we can say of. So 4/3 of yellow equals green. So we have 4/3 of the yellow one is what the green is worth. Okay, so green, if you wanted to read it backwards, green is 4/3 of yellow. And it is, because green is larger. 4/3 means it's greater than a whole. It's larger than the yellow one. All right, so we're going to flip our page, and we get to kind of make up our own situation here. It says, make up your own blue and red sand mixture. Your picture should have a total of 5 parts. Draw a tape diagram to show the ratio of blue to red. All right, so we get to make it up. It needs to have a total of 5. Let's make a tape diagram here. Let's make this my blue, and it can have 2. And what do you guys think? If I'm supposed to have a total of 5, how many should my red have? Yeah, it should have 3, because if I have a total of 5 and I already used 2 for blue, then that means my red has to be 3. So I made that up. The book did not tell me it had to look like this. It just said I had to have a total of 5 parts. So if I wanted to, I could have made 3B blue and 2B red, or I could have done 1 blue versus 4 red, or 4 blue versus 1 red. There's lots of different ways to do it. However, the total must be 5. So we get to describe the ratio of blue sand to red sand in 3 ways. So we've got blue to red, which means blue has to come first. So one way I could say blue to red is, I'm going to do blue first, 2 to 3. I could say blue to red is 2 to 3. That's another way I could say it. I could also say there are 2 parts blue sorry, my son was in here. I had to tell him to go away really quick. There are 2 parts blue and 3 parts red. Okay, so those are 3 different ways I could say it, right? So we've got blue to red is 2 to 3, blue to red is 2 to 3, just written a different way, and there are 2 parts blue and 3 parts red. All right, well now it says, describe the ratio of blue sand to the total mixture. All right, so before it was blue sand to red sand, now it's blue sand to total. Well, what is our total? How many total parts are here? 1, 2, 3, 4, 5. So our total is 5. So if I want to do blue versus total, I could say blue to total is 2 to 5. Because there's 2 parts blue and 5 parts total. Blue to total is 2 to 5. Again, just writing it a different way. Instead of the word 2, I can use the colon in math to show the word 2. And I could also say there are 2 parts blue and 5 total parts. Okay, so hopefully this is pretty simple. I feel like when you're just doing the one number ratios, it's a lot more easy to wrap your head around than when you're doing the multiplicative comparisons with the fractions. That's when it gets confusing. And that's what our next question is asking us to do. Now write 2 sentences that use a fraction to compare the amounts of the 2 colors. And they want us to use the words times as much. So that has to be in our sentence. So if I want to do times as much, I'm going to say, I'm probably just going to not talk about the total. Personally, I think it's easier if we don't talk about the total. So maybe I'll say blue, one way I could say this is blue is 2/3 times as much as red, because blue is 2/3 the size of the red one. So if this is how much red is there, blue is only 2/3 of that, okay? And if we work backwards, we can say our other sentence. We could start with red and we could say, well, red is 3/2 or 3/2 times as much as blue. It's just going opposite. So red is 3/2 or 3/2 as much as blue is. All right. Suppose you make a large batch of your blue and red sand mixture. Let B be the number of cups of blue sand that you're using. Let R be the number of cups of red sand that you use. Write 3 equations relating B and R. Okay, so to me, this reminds me of this down here. What are the 3 different ways we can represent this? So the first one I'm going to write is just a basic proportion. If I want to do B versus R, that's going to be how many blues? There were 2. How many reds? There were 3. So to me, that one's pretty simple. B versus R is equal to 2/3, okay? Then I can say for my next one, what if I want just the blue? Well, I'm going to turn this sentence right here in number 25 into an equation. Blue is, in math, is means an equal sign. So blue equals 2/3 times, which means we're going to multiply, as much as red. So that's what this equation says. Blue is 2/3 times as much as red, or blue equals 2/3 of red. Well, we could also do the opposite, which is this next one that we did on number 2. We said, on number 25, for our second one, we said red is, which would be R equals 3/2, or 3/2, times as much as blue. Okay, so R equals 3/2 of B. So all 3 of these are different ways that you could write the equation. And our last question for today's math says, how is your mixture different from a mixture with the same colors mixed in a different ratio? And what that's asking is, at the beginning, they said, hey, make up your own ratio. So they're saying, what if you did something different? What if instead of blue 2, red 4, what if we only did blue 1 and red, blue 2 and red 3. I think I said 4 up there. I messed that up. We wrote blue 2 and red 3. What if we changed it and it was blue 1 and red 4, right? What if you changed your ratio, even though the total was still 5? They're saying, how is your mixture different from a mixture with same colors in a different ratio? So our mixture could be more blue or it could be more red. Now in the case right here, our mixture would be more blue than this one, okay? Because we had 2 parts blue and they only have 1 part blue. Or another way we could say that, it could be our mixture was less red than this one, right? This one only has 3 parts red, this one has 4 parts red. So our mixture could be more blue or more red, or it could be less blue or less red. It really just depends on which color you're talking about and how you changed your ratio. So there are lots of things to think about with ratios. I feel like every day it's getting a little bit more complicated. So if you guys have any trouble with this when you're doing your homework, you can try to watch the Whitney Billman video on YouTube. And if you can't reach it on YouTube, you guys can log into Microsoft Stream. That's one of your My Apps. And Miss Billman has those loaded on there. If you need help finding her videos, you let me know. If you still need help after watching my video and after watching her homework help video, you shoot me a message either on email or on your parents' dojo, and we will do a one-on-one Zoom to get you some more help. All right, thanks guys.